We're going to look at a few examples of how we could factor by grouping. And when we're going to use this is if we have a polynomial with 4 terms, but we also use it with polynomials of 3 terms, trinomials, where we can rewrite it to make it have 4 terms so that we can use this method. So we're going to use this method for a lot of different types of problems. So let's start with an example that does not have a greatest common factor. And then it's going to be the same process if it does have a greatest common factor, only we'll have that step first of finding what the greatest common factor is. All right, so we've previously learned how to factor a binomial. So if I only had, say, this problem here, or if I only had this problem here, we've already learned how to factor that, which is good because we're actually going to turn this into this first problem and the second problem. So instead of thinking of this as a whole brand new thing, really just think of it as factoring out that GCF of a binomial that we've already learned how to do. So I'm going to first just focus on this first set of factors here. The GCF of 6 and 9 would be 3. And then if I look at my x term, I took the smaller one, which is the x squared. So there's my GCF. So I'm going to divide out that GCF. 6 divided by 3. And then with my variables, I subtract the exponents. 3 minus 2 is 1, so I have a single x variable. And then 9 divided by 3 is 3. And again, subtract the exponents on the variables. 2 minus 2 is 0, so that x just goes away. So that's that same thing we did, factoring out GCF of the binomial. And then we're going to look at the second one. So what is a GCF of 4x plus 6? And that's going to be a positive 2. And that positive or negative is always going to be based on this sign. If this sign is a plus sign, then we're going to have a plus sign down here. If that's a negative sign, we'll have to have a negative sign. And then we're going to divide out that GCF. 4x divided by 2 is 2x. 6 divided by 2 is 3. And if we did this correctly and is actually factorable, then we're going to have a matching set here. So 2x plus 3, those should match. And then that becomes one of our answers. So 2x plus 3 is one factor of this original polynomial. And then the other factor comes from the GCFs we factored out. So that 3x to the second and that plus 2 we have here makes up our second factor. And that's it. If you wanted to, you could check your work. And if we do distributive property and distribute here, we should get back to this polynomial we started with. Okay, so let's look at an example if we have a GCF and what that looks like. Because you're probably thinking we factored out GCFs, but that's a little bit different. That's within the problem. This is if we have a GCF in the problem itself. So let's look at this one because this will have a minus sign where the other one did not. So we can also see an example of that minus sign. Okay, so what I mean when I say it has a GCF, 10, 15, 20, and 30, I can divide all of those by 5. So this actually has a GCF of 5. It could have a GCF of a number like this. We could also have a problem that has a GCF that would just have a variable GCF. So let me write an example of what that might look like. We're not going to solve this one, so I'll write it over here. So what if we have like 3x to the 5th plus 2x to the 4th minus 5x to the 3rd plus 7x squared. So this one, for example, the 3, 2, negative 5, and 7, those do not have a greatest common factor other than 1. But they do have an x in common. We take the smallest x. The smallest x is x to the second, so the GCF here will be x to the second. The one we're looking at over here with GCF, this example, the 30 doesn't have an x, so that means our smallest x is none, so we don't have a common variable. So the GCF is just 5. And you might have one that has a number and a letter, kind of similar to how we did here. We had this number and a letter. All right, so let's factor this one. We're going to factor out, we're going to divide out that GCF first. So I'm going to divide everything by that GCF we found of 5. So 10 divided by 5. Because this one did not have a variable GCF, that means I'm just going to leave the variables alone. 15 divided by 5, 20 divided by 5, and 30 divided by 5. So all I've done is divide out that GCF. And then now this 5 is done. We're just going to drop it down, and it's going to be out front in our answer. I like to draw the arrow and drop it down right away. Otherwise, I tend to forget about it, and we do have to have that as part of our answer. So now we're just going to group the first two and group the last two together just like we did before. And from here on out, the steps are the same. So what's the greatest common factor between 2 and 3? It's just 1. You can write the 1, you can choose not to. And then the variable, the smaller one, is the second power. So that's our GCF is 1x to the second. So now I'm going to divide by that. 2 divided by 1 is 2. Subtract the exponents, 3 minus 2 is just 1. 3 divided by 1 is 3. And subtract the exponents, 2 minus 2 is 0, so that goes away. Okay, so again, we said whatever this sign is negative this time. That means that I need to drop down a negative also. So now when I factor out of my 4 and 6, the GCF is 2. What I actually have is not 2, but negative 2. So I'm dividing out negative 2 instead of just positive 2. And we can check. If I had just put this as positive 2, if I did this negative 4 divided by positive 2, I would get a negative 2. But remember, these are supposed to match. So I have to make sure I get a positive 2x inside here. So that's how I can know how I can tell I need that minus sign. Negative 4 divided by negative 2 is positive 2. And we still have that x attached. And negative 6 divided by negative 2 is positive 3 that we needed to make those match. So then one answer is going to be that 2x plus 3. The other part of my answer is made up from the greatest common factors. So the greatest common factors was the 1x to the second and the minus 2. So I have the x to the second and the minus 2. So this factor by grouping step is what we're going to use over and over again. There is a way we can do this GCF at the end if you had forgot. So let's look at that real quick. I'm just going to move this stuff over here. So let's get rid of this stuff over here so that we can rework that problem. Okay, so we're not going to look at the no GCF anymore. We're going to redo this problem over here. 10x to the third plus 15x to the second minus 20x minus 30. So what if we did not see or forgot to check that the greatest common factor was 5 and we just started grouping, which is perfectly fine. So I start by grouping. The GCF of 10 and 15 is 5, and then we have that x to the second as a smaller one. So I'm dividing out that, and that's going to be 2x plus 3, because 15 divided by 5 is 3. There's that negative sign, so factor out a negative sign. And then I can factor out a 10 between 20 and 30. GCF is 10. Then I'm going to divide out that 10. Negative 20 divided by negative 10 is 2x, and negative 30 divided by negative 10 is positive 3. And again, these should match. So there's my one answer, 2x plus 3. My second answer comes from my greatest common factor, so 5x to the second, and the minus 10. So if you're looking here, we have a partial match. We have a 2x plus 3 and a 2x plus 3. But this other factor doesn't match. We have an x squared plus 2, minus 2, and a 5. So if I look at this one right here, this factor is actually not factored completely. It's factored, but not completely. And the way I can tell is that the numbers inside here should have a GCF of 1, like 2 and 3. GCF of 2 and 3 is 1. But GCF of 5 and 10 is not 1, it's 5. So I can actually factor this one some more. So I can divide out a 5, and then when I divide that out, I get x squared, because 5 divided by 5 is 1. We can choose to write the 1. Negative 10 divided by 5 is negative 2. So now we already had that 2x plus 3. Now here's the 5 that we needed, and here's the x squared minus 2 that we needed. And then we just like to write this nice and neat. This number here just gets written in front. And then we have our two factors, and it really doesn't matter which order we write these in. So these are now the same answer. It doesn't matter that I write them in different order. So if you forget to factor out your greatest common factor, you can do that at the end, but make sure you do it at some point.